Okay, this was the problem I left you with last time. And if you remember, I asked you to actually calculate the value of V in that really brings us to this switching condition. That is when V1 is equal to that reference voltage. And so I'm just going to equate this now to that reference voltage. Now this is a specific value of V in, so let's label that. Now remember what's going to happen here. When V1 becomes equal to the reference voltage, remember the initial condition of V out was a minus 15. So when this V in is increased, this increases. Eventually this guy's going to be just a fraction bigger than the voltage at the inverting input over here. At this switch point, this output's going to do what? It's going to switch from a minus 15 to a plus 15. That's assuming our power supply is a plus and minus 15. So let's talk about this as being a specific value of V in that's brought us to this switch point. Let's call it V in H, because our output's going to go what? From basically a low or a minus 15 to a plus 15, which we can call a high, as it were, condition. All right, let's now see if we can determine what V in H is. All right. Let's go ahead basically and multiply both sides of the equation by R1 plus R2. So what do we actually get? All right, so taking this term over here, we're multiplying through by R1 plus R2. So we end up with just what? R2 sitting here times V in H minus, this is going to be R1 times 15, and that's equal to R1 plus R2 in brackets here times that reference voltage, Vref. All right, so remember we're trying to find V in H. All right, what next? Well, let's take this guy over to the other side. And so what we have is R2, V in H is equal to, well, we've got this guy over here, which is R1 plus R2, bracket, times V reference. We brought this to the other side, which becomes a plus R1 times 15. Okay, so if we now divide both sides by R2, then we're going to get V in H being equal to R1 plus R2, bracket, over R2 times the reference voltage plus R1 over R2 times 15. So we now have an expression for V in H. So let me just show this graphically. I'm going to have a diagram here, which we're going to say is the output voltage, let's say, versus the input voltage V in. And so what we've seen over here is we've been at a minus 15. We've got to a particular value of V in, which is V in H. So that's our V in H value. And what have we done? We've actually switched from that minus 15 over here really to a plus 15, okay? So really at this point now we could say, going back to that car example, the radiator example, we could say now this plus 15 is used basically to turn on the motor and start cooling the actual radiator itself. And so the radiator will now start to cool. The big question though is, do we switch back at the same place? Or do we switch back somewhere else? And so now let's consider that. So after we've switched, of course, this output voltage is a plus 15. So our condition is a little bit different now, okay? So remember our expression for V1, which is a function of V in and this output voltage. This is no longer a minus 15, it is a plus 15. So we now need to establish the switch point again. When does that occur? Well, same story. When V1 is equal to the reference voltage. So what's happening here? We're going to reduce V in until we make this value V1 equal to the reference voltage. All right. So let's be a bit more specific in this equation, and we're going to say then that switching is going to occur when V1 is equal to that reference voltage. All right, let's put that in this equation, Okay, and it's going to be a specific value of V in, isn't it? Yes. So let's do that. So we've got R2 over R1 plus R2 times V in. Now this is going to switch back from what? A high to a low, or from plus 15 to a minus 15. So we're going to call it V in L plus R1 over R1 plus R2. The value of VO though, right, is what? It's a plus 15 this time, so that's a 15 sitting here, and that is equal to our reference voltage, like so. So what we've got to do now is determine this value of V in L. How do we do this? Well, let's go ahead and once again multiply through by R1 plus R2. So what have we got? We've got R2 V in L, okay, plus R1 times 15 is equal to R1 plus R2 times that reference voltage, okay? Taking this guy over to the other side, we have what? We have R2 V in L is equal to R1 plus R2 in a bracket times the reference voltage. This to the other side is a minus, is it not? R1 times 15. Okay, so therefore V in L is equal to R1 plus R2 divided by R2 times the reference voltage minus R1 over R2 times 15. Okay, and you'll realize now that this is a smaller number than V in H because of this minus term that's sitting right here. Okay, and so therefore I have to actually reduce this V in to a value here of, and I'll show you this over here like so, of V in L. Okay, and then we will switch from a plus 15 back down to a minus 15. And in the case of the car, what are we really doing there? We're turning off the fan, which is cooling the radiator. Okay, so what I'd like you to do now is actually determine the difference between the V in H and the V in L. Okay, and that's actually referred to as the hysteresis value. So see if you can have a go at this, and when we come back next time, we'll actually do this together.